This piece of music is composed by the AI, the neural network. Let's see how it does it. This is one of the assignments I took in the deep learning courses. And in this assignment, you need to create a jazz solo with our LSTM network. LSTM stands for long short-term memory. Let's see how it does it. The problem statement of this assignment is quite interesting because you want to create a jazz music for a friend's birthday, but you don't know how to play instruments or music composition. Fortunately, you know deep learning that will solve this problem using an LSTM network. You're going to train your algorithm on a corpus of jazz music. In this assignment, you are assigned 60 pieces of jazz music. Each of them consists of 30 seconds. And for all the jazz music, there are 78 unique values, which means you can represent that as 78 unique notes for all those 60 pieces of jazz music samples. So you can see the number of training samples 60, and each of them has 30 seconds. The total number of unique values are 78. To train this model, we feed into those 60 jazz music into this neural network one at a time. So those axes represents each of the note in sequence. The Y is always the following note followed by this X. So what you need to do is feed those 60 jazz music one at a time so that it fine-tunes the neural network. As a metaphor, you listen to 60 pieces of music 100 times. After listening those musics, I'm sure you can also create certain intuitions about the next note if you listen to the first note. So this is what the neural networks is all about. Is create that intuition of the next note followed by the note they just heard. So now I'm going to introduce a very important concept, which is the hidden state. So there are 64 hidden states for this neural network. What does that mean? That means that for each node, there are 64 attributes about this node. It can be sadness, happiness, and anything abstract. But one node, there are 64 hidden states of that node. There are 64 attributes of each node. So that's how we define the complexity of the network. And you can see later on, when you train a model, you specify that TX30 means it's 30 seconds. NA means each of the node there is 64 attributes, and N values means there are 78 unique X values. Then you define some cost function or loss functions. So those functions defines what predicted versus what's the actual node. And then you will find the difference, and the neural network will say, oh, there's a difference between what I predicted and what the actual node is. And when we calculate that difference and feed back into neural network so that in the next time, your predicted one will be closer to the actual node. So that's all this is about. N equals 60 means there are 60 jazz music to train. Epoch means you run those 60 pieces of music 100 times to this neural network. And you can see the loss function here as it printed out. And here you can see the loss function. It starts with a loss of 125, but as it goes over time, it reduces to 62. And if it keep going, so this is epoch 43 out of 100. And here you can see the loss reduced to 16. And to the end, you can see the loss is now only 6. So this means what we predicted node becomes very closer to what the actual node is. So this means your neural network is improving. Once you train the model, predicting becomes fairly simple. So now you've already let the neural network listen those 60 pieces of music 100 times. So those neural networks or those brain cells are fine-tuned for jazz. So now what you need to do is just to feed into the first note of the jazz music, and the brain will predict the next note Y1 and feed this back into the second time iteration as an input of the second LSTM, and use that to predict the third note and feed this third note back into this neural network to predict the fourth note, and so on and so forth. And this is how the neural network creates the piece of music. What you need to do is train the neural network, feed the first note, so the neural network will figure itself to predict the next note, and use the next note to predict the third note, use the third note to predict the fourth note. And the entire process, we can call it as an inference model. And for the last step, we feed this inference model, becomes the input of this generation music. Generating music is a function that post-processing the music to make it sound more natural. And after that, we create this piece of music, just we heard as before. This is a very interesting project, and you can see how a neural network can compose a piece of jazz music by only listening 60 pieces of jazz. And looking forward to seeing how neural network can achieve in this music industry in the future. Thanks for watching.